Our presentation on muscle contraction, specifically the sliding filament mechanism, does not have the drawing reflect in the beginning where the synaptic knob meets the cell, but rather where the tripomyosin, which has the active site, has the actin introduced to that location. So although the presentation will mention the preceding steps, the actual drawing only starts in midstream, but we want to make sure that we mention all activities and words required. Having said that, we'll move you along to the drawing. Okay. So as I've indicated, the action potential arrives at the synaptic knob prior to the specific drawing here. The calcium channels in the membrane open up, permitting the calcium to flow through and into the cell. As the calcium increases, it causes the synaptic vessels to fill with acetylcholine and to marry with or fuse with the membrane. As the acetylcholine, or ACH, is released from the synaptic knob by way of exocytosis into the synaptic cleft, the acetylcholine is picked up by receptors, specifically acetylcholine receptors, on the motor end of the skeletal muscle. At this point, the channels, the sodium-potassium channels, permit the sodium ions to go into the muscle fiber. The increase in the positive ion inside the muscle, and it continues, initiates the action potential on the sarcolemma. As the action potential travels down the sarcolemma into T-tubules, it activates or stimulates the release of calcium from the terminal cisternae of the sarcoplasmic reticulum. Note, this houses or sequesters the calcrestium. And again, this is released, the sodium, into the sarcoplasm of the muscle cell. At this point in time,
the calcium floods over the thin filaments and binds to troponin, pulling tripomyosin off the active site on the actin. The high-energy myosin head leaps to bind to the exposed active sites on the thin filaments, forming a cross bridge. The myosin head pivots to the low-energy state, releasing ADP and moving the thin filament over the thick filament, which is called the power stroke. ATP binds to the myosin head, causing the head to break free from the active sites on the actin. The myosin head then becomes energized as ATP is converted to ADP. Calcium is pumped back into the SR and attached to calsequestrin, allowing tripomyosin to once again cover the active site, resulting in relaxation of the muscle.